So 2.4, a second day. We need to talk about conjugates. We talked about them last year a little bit. It's something that people like to forget, but it's there. We have x minus y and x plus y. Isn't that also known as the difference of squares? Okay, so conjugates form the difference of squares that we can factor. See that? So when we have a conjugate, the whole point is to zero out that middle term. Right? It zeroes it out. So we can use the conjugate to help us simplify complex numbers. Also, we can use it to simplify when we have a square root quantity involved. There's lots of places conjugates come up that we will use. So the complex conjugate, the only reason it is a complex conjugate is it involves the BI. Only reason, okay? So it's A plus BI and A minus BI. And the only reason it says complex is it's because it's a complex number, has the imaginary number in it. If you want to make your life better, just call it all a conjugate. Got it? I love it when I'm doing with square roots or radicals and somebody goes, multiply by the complex conjugate. Well, it's the conjugate, but it's not the complex conjugate. So down here we have A plus BI, A minus BI. So you'd have B squared minus ABI plus ABI minus B squared, I squared. Well, the I squared would make it a positive. And now you don't have a difference of squares, you have a what of squares? Up here we had a difference of squares. Down here we have a what of squares? Sum. So with imaginary numbers, we are allowed to factor the sum of squares. They are not real solutions, but we are able to factor it. So if I had x squared plus 16, well, you want to factor difference of square. So, but what do you have to put with your 4? I. Because when you multiply this out, you would get x squared minus 16i squared. And the I squared would make the 16 a what? Positive. So now it is possible to factor the sum of squares as well. But do I get real solutions? No. Tell me when I'm good, guys. Well, they're not. They're still writing over there. The mad dash.
How'd your game go? Did you win? Why do you have writing on the back of this chair?
On me?
Yeah, you're sitting in it.
I don't know.
You two done yet?
No, I'm done.
What does it say? 287 or something like that?
It's like 2 times 7. Like also, some was scribbled out in the top. Well, if they're attempting to do math, I
I
guess.
did math on a chair.
They ran out of paper.
Oh, I think it's the room number because this one has 207. Same with Riley's.
Okay.
We got that figured out.
So multiply each complex number by its complex conjugate. Okay, first thing we do is we have 1 plus I. First thing we do is put parentheses around it so we see it. And so we're going to multiply by 1 minus I. Bless you. So I have 1 minus I plus I minus I squared. So plus minus I go away. And the I squared becomes negative 1. And a negative 1 is what? So 1 plus 1 is 2. So, what is going to happen when I multiply by a complex conjugate? Am I going to have any imaginary number at all? No, I'm going to get a real number. So if you multiply by a complex conjugate and don't get a real number, you didn't do it right. Clear?
Yes.
Okay, so I have 4 minus 3i. 4 plus 3i. Okay, we're going to do all these and then you're going to multiply them out. Okay. I have the square root of negative 15. What do I need to multiply by? That's a horrible.
Root over positive.
I don't agree with this. I'm going to say 15. Square root of negative 15. Because the conjugate is, well, okay. I'm going to start over with my words. Okay, I have the square root of negative 15, and it's a positive, yes?
Mm-hmm.
So it's negative the square root of 15. Negative 15. The inside stays exactly the same, is what I'm trying to get at. It's the outside that changes. Yes?
Yeah.
Okay, so they have 1 plus the square root of 8. 1 minus the square root of 8. Okay, so you got 3 to do.
You doing anything? No, my nose is killing me.
Well, grab them tissues.
I have one.
Keep blowing.
Except for like 1 week a year where I'm just sick.
Okay, so did you get 25, 15, and negative 7?
Yes.
Yes? Okay. Questions before we move on?
No.
No.
Okay. Okay, so now why would we use a complex conjugate? You can't have a radical in the denominator, can you? Nope. You also cannot have an imaginary number in the denominator. Because an imaginary number needs to be written as a complex number needs to be written as a plus bi. Yes? Totally separate. This is not separate. It is one thing, correct? So we need to multiply both the numerator and the denominator by the conjugate. So what is the conjugate?
1 plus I.
So 1 plus I and 1 plus I. So you do it and I do it. We better get the same thing, right?
Is it my first day after school today?
A little bit, yeah. Okay, did you get negative 3 plus 3i over 2?
I sure did.
Okay. What?
You said yeah.
Oh, I thought I said no. I moved this to the front. Why? Right, you have to have the real number to the front, yes? Okay, but I still don't have two pieces, do I? Do I? No. If I can make two fractions one because they have common denominators, can I pull it apart too?
Yep.
Yeah. So I can write it as negative 3 over 2 plus 3 over 2i. Now, that I is not in the fraction. Do you see that? Okay, normally, like if it was an x, we could write 3x over 2 and we'd be good, couldn't we? But with the imaginary number, it needs to be 3 over 2, and I don't know why I just chose negative I. Needs to be off to the side. So that's why we have complex conjugates.
It's so easy.
Good.
And
Okay.
that's all we're doing today.
Pretty much. You're manipulating them. Okay, write the quotient in standard form. So standard form is what?
A plus B.
Okay, a plus bi. So we can't have this in the denominator, can we? Okay, so it's going to be 1 plus 2i. And guys, I just write it in the middle over here and take it to both. I'm lazy. Remember, efficiently lazy? Okay, so do that. Got it? You got it?
What did you do?
What do you mean, what did I do?
Wait.
Did you get 6 plus 12i minus 7i plus 4 minus 14i squared?
Yeah.
Okay, so the I squared was negative 1, so that made these two positive. Right here and here. And then 14 plus 6 is 20.
I just need to add my like terms together.
Yep, combine your like terms. So, did you guys get 20 plus 5i over 5?
Yeah.
Now, what do I need to do with it?
Do 20 over 5 plus
I need 20 over 5 plus 5 over 5. So I get 4 plus I. If I did that right. We're doing some algebraic tumbling. I can't say gymnastics, we're just tumbling. Calculus is gymnastics. I told them they were doing gymnastics. So ask Natalie how her back tuck is coming in calculus.
I will.
Ask
Next
her.
hour.
Ask her.
You ever in your college question?
Okay, now if I need to add two fractions, I have to get what? Common denominators. Now, there's two ways I do these problems. If I see that their denominators are conjugates of each other, I just multiply each fraction by the other one. Okay? If they are not conjugates of each other, I do each fraction like we just got done doing. I would do this fraction, I would do this fraction, and once they had a whole number denominator, then find common denominators. Does that make sense? But do you see that these are conjugates of each other?
Yes.
Yeah.
Okay, so that means I'm going to multiply this side by 2 minus I, right? And this side by what? 2 plus I. And it's all going to make it one nice big common denominator. Good job. Did you guys get 12/5 plus 9/5 I?
Not yet.
Not yet? Okay. Are you on your way?
Wait, do I need to always put it in those mini fractions?
And the two different fractions? Yes. Always. Now do we got it?
Yep.
Okay.
I'm lost, but
You're what?
I'm lost. I did something.
Okay, so look at what I did. Did you get 4i and it should have been minus I squared, 2i squared?
4i squared minus 2i squared.
No, it just would be 4i. Because it'd be 2 times 2i would be 4i. I think that's probably where you messed up. And then did you get 10 plus 5i for the other one?
Okay, what?
Did you get, for this part, did you get 10 plus 5i?
No.
What'd you get there?
Yeah. Oh. Okay, yeah.
Okay, so all you did is you put I squared on that very first 4, and it shouldn't have been squared. Because it's just 2 times 2i. See that?
So did you add the other or no?
Yeah, well, because it was negative, it was negative 2i squared. So then it made it plus 2. So the 2 and the 10 and the 4 and the 5.
Okay, I see.
Am I good then?
Yeah.
Okay.
It's just-
So they don't have common denominators. We're going to approach this. We're going to do the left-hand fraction, the right-hand fraction, or do you want to just multiply one side by the other? You tell me.
I don't know.
We can do it either way. Do you want me just to show you the other way?
Yeah.
Okay. So what I do is, like I said, I focus on the left, and I touched it. I focus on the left, I focus on the right. Okay? So the left, the conjugate, we could do negative I, or we could just do I. If we do a negative I, we get a positive 1. So we'll just do negative I over here, keeping with the conjugate thing, right? And over here, we're going to do 4 plus I. Okay, so then I would have what? Negative I minus I squared over negative I squared. So I get 1 minus I over 1. Is that what you got? Okay. So on the next one, I'm going to change it to a plus, and I'm going to have 16 minus I squared in the denominator. You know that one already, right? Okay. The reason I changed it to a plus is because this negative is going to go with that 3. Okay?
Wait, don't you get rid of the I squared?
Yeah, I will. I'm just worrying about the numerator. So it's going to be negative 3, so it'd be negative 12 minus 3i. So yes, the denominator would turn into positive 1 there, right?
17.
So it's 17. And I have negative 12 minus 3i. So I multiply the left one by 17.
Ew.
Well, that's not hard. It'd be 17 minus 17i. Correct?
Yeah.
Okay, so my common denominator is 17. And I have 17 minus 12 is 17 minus 12. 5. And I have negative 17i and negative 3i, so I have negative 20i. And so hopefully you still can go down. So 5/17 minus 20/17 I. And if I could reduce one of those fractions, I would. That's it.
What did you just do?
I just separated these two.
No, above that.
Above that, I multiplied this. I don't know, I erased it. This by 17.
Okay.
So I got 17 minus 17i. And then I combined, I have 17 minus 12.
Ooh,
Okay, so you see how that works? You get your common denominators after. We could have multiplied this side by 4 minus I, and this side by I, if we wanted to.
Easier.
17, couldn't you just cancel out the ones?
No, because that's a quantity. Don't even do that. Put those parentheses. So, she just asked me a question, is it easier that way? So you don't need to write it down. I'll just work it and you tell me if you think it's easier. How about that? Okay? So I do put my parentheses so I don't screw it up. And I'm just going to do I. So my denominator would be this times this, yes? I'm pointing and you can't see. This times this. So it'd be 4i minus I squared. And my numerator would be 4 plus 4i minus 1i, so minus plus 3i. And then minus I squared. This would be a negative 3i. So this would be plus 1. And this would be plus 1. So my new fraction would be 1 plus 4i over, well, these would zero out, yes. And I get 5. But then I have to multiply by the conjugate, 1 minus 4i. So I'm going to have 5 minus 20i in the numerator. And in the denominator, I would have 1 minus 16i squared, which would make it 17 and 5 and 20i. So it's whichever way you would rather do. I had to do the conjugate either way, didn't I? You either have to do it at the beginning. Some people don't like it because they're like, well, you have to do it twice at the beginning. Okay, if there was a quantity here, like if this was 6 minus I, you'd have to do it twice, right? Well, you have to do it either way. It doesn't matter when you're doing it, you're going to have to do it. Does that make sense? So to me, I don't care. I prefer this method right here. I found that I tend not to mess it up. But I do this method if the denominators are conjugates of each other, because then I'm not going to have to do it again. So it's up to you. Questions? Okay. We got more. Oop, only 2 more. Okay, so we got to solve the quadratic equation. So we could factor this x squared plus 4, or we could use the quadratic formula, couldn't we? Yes?
But we can factor it.
But we could factor it too, because we know how to do sum, right?
Yeah.
So it'd be what, Cadence?
X plus 2, x minus 2.
What are you missing? It's a plus 4. So be careful with that, okay? So then we would get x equals plus or minus 2i. Yes?
You put 2 plus 2 i's.
Oh, I put two pluses. You're right. One should be a minus. Okay, there's another way I could do this. Could I subtract the 4 over?
Yep.
So I'd have x squared equals negative 4. And then I have to take the square root. So x would equal plus or minus 2i because of the negative. Or b is 0, isn't it? Okay, or I could do 0 plus or minus the square root of 0 minus 4ac. So
Let's not do that.
minus 4ac. So minus 16. Yes?
Yep.
All over 2a. So then I would have plus or minus 4i over 2, which would get me what? Plus or minus 2i.
Let's not do it that way, though.
Any of those ways work, correct? I don't care which one. So now I have the factors of 15 that add to 2. Does that work? Yeah, we want add, yes. I can get the factors of 15 that have a difference of 2, but that's not what this says, does it? Okay, so can we factor that?
No.
No. So we have to use the quadratic formula, correct? So negative b plus or minus the square root of b squared. So that'd be 4, right? Minus 4ac. Well, ac was 15, right? All over 2a. So 6. So 4 times 15 is 60. 60 minus 4 is 56. So I have negative 56. So the square root of negative 56. So I have 2 plus or minus. Well, 56 is what times what?
8 and 7.
8 and 7, or 4 and 14? Yes? Why did I change from 8 and 7 to 4 and 14? Yeah, because 4 is a perfect square, right? I kicked a 2 out of 8. So that would be 2, the square root of 14, I. Where'd the I come from? The negative 56, all over 6. What can I take out of 2, 2, and 6? 2. So that becomes a 1, and a 3. So that gives me 1/3 plus or minus the square root of 14 over 3i. Why did I have to do that?
Negative.
I have to write it as a complex number, right? So x equals that. Is that a real solution?
No.
No, but is it a solution?
Yes.
Yes. It doesn't say find all real solutions. It says solve. Got it?
Yep.
Okay, last one. Oh, do you all know the quadratic formula?
Write it down again.
Write it down again if you don't. What was it?
Negative b plus or minus the square root of b squared minus 4ac over 2a.
divided by 2a.
Yep. It's not a very good round. Okay, simplify the complex number and write it in standard form. Okay,
What this is?
what is this? Oh no.
This is.
Okay, so I have the square root of negative 2 to the 6th. Yes? So every 2 is negative 2, isn't it? Like every 2. So this would be, I always touch it.
Should be
So this would be 2. Can we write this as the square root of negative 2 squared to the 3rd? Because a power to a power I multiply, right? Now, why'd I pick it that way? Because this is a what root?
square root
square root. So when you square a square root, you get what?
-2
You get -2
to the third.
to the third, which is -8. What if I'd done the cube root of -2 to the 6th? How would you have rewritten that one?
Take, like, put to, not square, but like cube it.
So I would put the cube
Cubed on
squared, right?
the 3 on the outside.
Well, the 3 up front is the cube root. This 3 out here is cubed.
3 plus 3 is 6.
No, multiply. When you do a power to a power, you multiply. Because like right here, 2 times 3 is 6. Okay, so when you cube a cube root, you get what's inside, right? And then -2 squared would be 4. So you just make it. Do you have a question?
Did you do answers?
Well, yeah, because this is cube root and this is squared root.
Okay.
Okay, so I have 1 over 2i cubed.
Okay.
So I have 1 over what?
Don't worry, I'll go.
Well, steps first.
1 over 8.
8
Cubed.
I cubed. Yep, steps first. Then I want, what is I cubed? Negative I. So this is negative I. So I get 1 over -8i. Can I leave the I in the denominator?
Oh, you have to multiply by 8i.
No, just I.
You have to multiply by I.
We can do the 8, but that would be silly because then we reduce it out. So I get I in the numerator, and I get -8i squared in the denominator. So that's multiplied by -1. So the answer is
I over 8. Or -7.
no, I over 8. Can I leave it I over 8? Because I has to be out. Yes? What's next to the I? What number is next to the I? 1. So I should write it as 1/8 I. Remember, your I should always be, we don't like those imaginary numbers. Kick them out.
No, why are we doing them?
Because we have to. Because imaginary numbers, didn't I tell you last year where they are used a lot in electricity? Now think about that. If they couldn't figure out electrical calculations, think about how your life would be different today.
We don't have electricity.
And what does that mean with no electricity?
No,
No
nothing.
technology.
No technology. None.
We'd still be living back in the day.
Bladen's like, I got a pencil. It wouldn't been made in a factory.